Good morning, students. Today we will start our next chapter, okay, which is structure of atom. So in third chapter you have studied about atoms and molecules as well as of charged particles. So scientists were curious about to know the structure of atom. Okay, you might have seen that when you will rub a comb in your hair, and then you will, if you will bring that closer to the small pieces of the paper, that will attract the pieces of paper. Okay, one more example is that when you will rub a glass rod with a silk cloth, okay, and that then bring that glass rod near uh, to an inflated balloon, what will happen? Okay, they will attract. Why they will attract? Because there is localization of positive and negative charge. That is why they are attracting. So it means positive and negative charge is there in an atom. Okay, so discovery of positive, negative charge and neutral particles was done. Okay, the negatively charged particles, they were known as electrons. Okay, they are known as electrons, and it was J.J. Thomson who discovered electrons. Clear? Who discovered electrons? It was the E. Goldstein who discovered canal rays. Okay, these are positively charged rays. Clear? You can say it or call it as proton. And it was Chadwick who discovered neutron. Okay, neutron having no charge, electrons having negative charge, protons having positive charge, and neutron has no charge. Okay, so if I will ask you, uh, what are canal rays, then canal rays are the positively charged radiations. Clear? Now let us discuss the structure of atom. The first structure was given by Thomson, and it is known as Thomson's model of an atom. Thomson's model of an atom. First, it was the Dalton's atomic theory, okay, which suggested that atom was indivisible, okay, but later on studies were done, and it was uh, uh, it was found that atom has charge. It means positive and negative charge. It means subparticles must be there. Okay, so the first model of atom was given by Thomson. Okay, according to this model, he said that atom is like a sphere or the watermelon type. Okay, uh, on which the electrons are studded or embedded. Okay, just like this. It means electrons are studded on the sphere. Okay, these are negatively charged. These are negatively charged, and this part, rest of the part, is positively charged. Rest of the part is positively charged, and the of magnitude of positive and negative charge is equal. That is why atom is neutral. That is why atom is neutral, but he could not give the experimental uh, validation for his model. Okay, for this model, it means it was a theoretical concept. Experimentally, it was not proved that atom has this type of structure. After the Thomson's model, the next model was given by Rutherford. Okay, Rutherford's model of an atom. Okay, he could not, Thomson could not give the experimental validation of his structure. He was saying that negatively charged particles are there and positively charged particles are there. But which type of rays he used to deduct these positive and negative part of atom? Okay, he could not explain that. So next was the Rutherford model. He used alpha rays. Alpha rays means Alpha rays means positively charged rays he used for his experiment. Clear? He took a gold foil which was very thin. Okay, these are the atoms. Okay, these are the atoms. In the center, it is nucleus. This small dot is nucleus. In this way, okay, he allowed these rays to fall on this gold foil. Gold foil means atoms are there. Clear? So what he observed that? He observed that the maximum number of lines or rays are passing through this foil. Okay, small number of rays, they are diverting or deviating through a small angle. Okay, through a small angle, and only 1% you may say that will go straight and will come back. Okay, that will go straight and come back by making 180-degree angle. Okay, it will go and it will come back. And this number was given, it is uh, 1 out of 12,000 particles. Okay, 1 out of 12,000 particles. Clear? That will go and will come back. Clear? This was the experimental model given by the Rutherford to have the idea of structure of atom. So what he, this is the experiment. Okay, how he conducted experiment. What was his observations? His observations, as I have told you, that maximum number of particles or the rays, they are passing straight from this gold foil. Some numbers of particles, they are deviating by making a small angle. 1 out of 12,000 particles, that is rebounding. Rebound means it will go and it will come back by making 180-degree. So from here he concluded that, okay, atom is like this. Okay, in a center there is a nucleus. In nucleus there is positive charge. Why positive charge? Because he was using alpha rays. Alpha rays are positively charged radiations. They are going in this way and same charges repel each other. It means if it is rebounding back, okay, it means it is striking with positive charge alpha rays which are positively charged. They are striking here with a positive charge, and that is why they are coming back. Clear? It shows that in the center, okay, nucleus in the center of atom, and electrons are revolving around the nucleus. Electrons are revolving around the nucleus. The magnitude of positive and negative is equal. That is why atom is neutral. Okay, this was the observation of Rutherford model. The last point of this model is a drawback. Okay, the accelerated motion is there. Accelerated motion is having in those bodies which are rotating in a circular path. Okay, those particles or bodies which are rotating in a circular path, they have accelerated motion. So what will happen? According to this law, electrons, this model, electrons are rotating around the nucleus, and the rotating body is having accelerated motion. So what should be there? It should be like this: electron, okay, accelerated, due to the accelerated motion there will be loss of energy, and ultimately this electron, it should fall in the nucleus. It means matter we are seeing or watching, it shouldn't be in that way. Okay, it means atom will collapse, but this is not a case na. Because if this will happen, it means atom is unstable. Atom is unstable. If electron having accelerated motion, then ultimately it will fall into the nucleus. It means that atom is not stable according to this model, but it is not the case. Atom is, we know that atom is stable. Okay, so this law couldn't explain the stability of the atom also. So it was all about the Thomson's model and Rutherford's model. In next video, we will discuss about the Neil Bohr's model of atom. Thank you and have a nice day.